Dear students, today we are going to discuss the stereoselectivity in aldol reaction. Now, in aldol reaction, two molecules of acetaldehyde in presence of base, both of them they react and we get one beta hydroxy carbonyl compound popularly known as aldol. This reaction is the first one and the conventional aldol condensation. Now, coming to the stereochemistry of this product aldol, if we investigate the structure, then we can see because of this condensation of the two molecules of acetaldehyde, we have created a new chiral center at the hydroxy bearing center because that carbon is attached with the four different groups OH, hydrogen, methyl and CH2CHO. Now, because of that there are possibility two. This aldol can be the R enantiomer or aldol can be the S enantiomer. Now, the question is, during this aldol condensation, whatever aldol we are getting we getting the only one or are we getting the two? If we get the two, then what will be the proportion of these two enantiomers? Actually, during this aldol condensation, we are not getting one enantiomer, but we are getting two enantiomers, and there is no selectivity, means the two enantiomers R aldol and the S aldol, they are produced in a 1:1 mixture, means we land up into a racemic mixture of the product. So, in one word, there is no enantioselectivity in our classical aldol condensation, where two molecules of acetaldehyde undergoes base catalyzed condensation to give rise to the racemic mixture of aldol. Now, as we know that aldol condensation can be of two types depending on the two components. If the two components are identical, then that is called as the self aldol condensation, and when we used to condense two different carbonyl compounds, then that is called as the crossed aldol condensation. Now, one example we can discuss here under the heading of the crossed aldol condensation, that is acetophenone having the alpha hydrogen undergoes the reaction with the base to get the enolate, and this enolate acts as carbon nucleophile which reacts with benzaldehyde which does not have any alpha hydrogen to give rise to the beta hydroxycarbonyl compound. Again, this beta hydroxycarbonyl compound has one chiral center. There are chances of getting two enantiomers, and during this condensation we land up into the racemic mixture. Now, coming to the other varieties of the crossed aldol condensation, if we select the two components carefully, then there is a chance that the product may contain two chiral centers on the side by side carbon atom. As for example, the 3-pentanone having alpha hydrogen, if undergoes the reaction with the benzaldehyde having no alpha hydrogen in presence of base, then the product contains the two side by side chiral centers, and now the diastereomers of these beta hydroxycarbonyl compounds are entering into the picture. All of us we know that any compound which will be having the two different chiral centers, those molecules will be having the 4 stereoisomers. So, in this context, our aldol product which we have got from 3-pentanone and benzaldehyde also will be having the 4 stereoisomers. Now, in case of the aldol, there are various ways are there to express these 4 stereoisomers, means by using RS nomenclature or by using the erythro-trio concept, we can be able to describe the 4 stereoisomers of this aldol product, where we have the two side by side carbon chiral centers. But in this case, these aldol products having the two chiral centers on the side by side carbons are expressed in terms of the Masamune nomenclature, where we take the help of the Syn and the Anti diastereomers. As already I have told that there are 4 stereoisomers of the product. So therefore, Syn means we will be having the enantiomeric mixture of the Syn means 2 in the at the same way Anti also will be having a pair of enantiomers. So in these type of cases, we will be getting a pair of enantiomers of Syn as well as a pair of enantiomers of the Anti. Now Syn and Anti, the stereochemical relationship between these two are diastereomers, and there is a chance that Syn will be major over the Anti or Anti will be major over Syn. Now in this discussion, that is only our point of discussion, how the aldol condensation will be diastereoselective, means under which condition Syn product will be more, under which condition Anti product will be more. But in this regard, I would like to mention one thing: whenever we get the Syn as a major or Anti as a major, those are diastereoselective definitely, but when we get the Syn, then under the Syn we get the racemic mixture of 2 Syn products. When we get Anti as a major product, in the same way Anti product means a racemic mixture of the enantiomers of the Anti. Now next, coming to the requirement of this type of aldol condensation, means in this case a prochiral enolate undergoes the condensation with the prochiral carbonyl compounds. Now what do we mean by prochiral? Prochiral means these are achiral molecules, but in one step this achiral compound will be converted into the chiral molecule. So therefore those achiral compounds are called as the prochiral compounds. Now our carbonyl compound having alpha hydrogen is prochiral, and this has the enantiotopic alpha hydrogens, because that achiral compound, that alpha carbon is obeying the pattern CABXX type, and if any achiral molecule has CABXX type of carbon, then those two X here hydrogen will be enantiotopic. Now when they are allowed to react with the base, then alpha hydrogen abstraction leads to the resonance stabilized carbanion, means the enolate. Now this enolate is allowed to react with the second component of the carbonyl compound, which does not have any alpha hydrogen, like benzaldehyde. Now this compound is also a prochiral molecule, and it has the enantiotopic phases, means the C double bond O of the second component has enantiotopic phases. Now when this enolate undergoes the reaction with the second component, then we get as usual a beta hydroxy carbonyl compound having 2 chiral centers adjacent to the C double bond O and the hydroxy bearing center. Now it has been observed that if the reaction proceeds for the carbonyl compounds through Z enolate, then at the end of the reaction we get Syn as major product, and if the reaction proceeds through the E enolate, then at the end we get the Anti as a major product. Now by using a proper scheme, we have represented this link between the E enolate and the Anti product, the Z enolate and the Syn product. So I repeat this relationship between these two, means if the enolate geometry is cis or Z, then we get the Syn product as a major over Anti. If the enolate geometry is trans or E, then we get anti as a major product over syn. Now coming to the method of preparations, means under which condition the reaction will proceed through Z enolate, so that at the end we will be getting syn as major over anti, and what are the methods that reaction will proceed through E enolate, so at the end we will be getting the anti as a major product over syn. Now, method number 1, if the carbonyl compound having alpha hydrogen has the bulky alkyl group, in that case there is a chance of getting the cis enolate, means the cis means the O minus and the alkyl group at the alpha carbon, they are cis, so that that alkyl group at the alpha carbon will be in the opposite direction with respect to the bulky alkyl group. So this is one way how to get the cis or Z enolate, so that when this enolate will undergo the reaction in the next step, the carbonyl compound having no alpha hydrogen, we will be getting the syn DL pair as a major product over the anti. Now we are going to the next method where we will be exploiting the boron chemistry. Now when this carbonyl compound having alpha hydrogen, one representative example what we have taken is the 3-pentanone, when it is allowed to react with the 9-BBN OTF or dibutyl boron OTF, in that case we will be getting the Z enolate, and the reaction end we will be isolating the syn DL pair as a major product. Now in place of these boron compounds, if we allow this 3-pentanone type of molecules, those are all prochiral molecules, allowed to react with the dicyclohexyl boron chloride, then these two, because of this big 2 cyclohexyl groups, the enolate will be having the E or the trans geometry, and when in the next step when it is allowed to react with the carbonyl compound having no alpha hydrogen, in that case we will be able to isolate anti-DL pair as a major over the syn. Now let us discuss the last type of category, where if our ketone comes under cyclic ketone, in that case we will be having always the trans enolate. So as a result of this, the final condensed product will be having the anti-DL pair as a major. Now coming to one very interesting thing about the stereochemistry of the aldol condensation of ester enolate, means not like what I have discussed in the previous case where the two components were the ketone or aldehyde. Now if the enolate comes from the ester, in that case there will be no diastereoselectivity will be there if we take the enolate coming from one ester. I want to mean in that case we will be having the syn and the anti 1:1 mixture. Now in such type of cases, the only one case I would like to mention, if the esters are originating from hindered phenol, in that case only we will be able to convert the trans enolate to the anti product and the cis enolate to the syn product successfully. Now how to get all these things, and there is no doubt about this, that this can be done in a little indirect way. Now, two sequences I would like to discuss. One is leading to the anti product with respect to the beta hydroxy ester, and another one is the beta hydroxy ester having syn stereochemistry. So as already I have told you, hindered phenolic ester if we use, that will lead to the E enolate, and from that we will be getting the anti product. Now coming how to get the syn beta hydroxy ester. Now this can be synthesized by taking the alpha hydroxy carbonyl compounds on treatment with the trimethyl chloride in presence of triethylamine, that silylation will be performed, and then if we treat it with the base LDA, then we will be getting the cis-enolate. And the cis-enolate, when it is allowed to react with the that another component of carbonyl having no alpha hydrogen, then we will be getting the syn product. Now in the next few steps, this syn product will be converted into the beta hydroxy ester, because although we got the syn product, but the ester is not there at the proper place. So now this is allowed to hydrolyze, so that OTMS will be converted into the OH, and then by using the par iodate, this molecule is subjected to the oxidative cleavage, so that we will be getting the beta hydroxy carboxylic acid. The byproduct of this oxidative cleavage is the IO3 minus and the acetone, and this beta hydroxy acid can be subjected to the esterification, so that at the end we will be indirectly we will be able to get the racemic mixture of the syn beta hydroxy ester. Now coming to the explanation of this diastereoselectivity in aldol reaction, means why from cis or Z enolate we get syn as a major product, and why from E or trans enolate anti product predominates over syn. Now this can be satisfactorily explained by using Zemmerman Trxlar model, according to which this reaction between enolate and the carbonyl compound proceeds through chair-like 6-membered transition state. So in order to apply this concept, we have to consider a chair form of cyclohexane, where the 6 points will be occupied by the 2 components. One is the enolate and another one is that carbonyl compound, where the nucleophilic attack will take place. Now as I have told you, this chair-like transition state has the 6 points, and the 6 points will be occupied by the specific atoms. Few are coming from carbonyl compound and few are coming from the that enolate. Now let us check that what are these 6 atoms. Now out of the 6 positions of cyclohexane chair form, the 2 will be occupied by the carbonyl compound, means the C double bond O, and the remaining 2 groups of the carbonyl compound, means one is the aryl group and another one is the hydrogen. Aryl group being the bigger group, it will prefer to go to the equatorial position, and that will give us the favorable orientation of the carbonyl compound, having the bigger group oriented in the equatorial position. Now as because it is the carbon is having sp2 hybridization, so instead of telling equatorial, we tell this as a pseudo equatorial orientation of the bigger group. Now coming to the enolate side, so enolate will occupy the 3 positions. So these 3 positions are 2 positions are occupied by the double bond of the enolate, and the another position will be occupied by the O minus of enolate. So previously, as I have mentioned, 2 positions are occupied by the C double bond O, and the 3 positions are occupied by the enolate. So 3 plus 2 is equal to 5. Now in the chair-like transition state, the only one place which will be occupied by the metal lithium plus, which will coordinate the 2 oxygens. One is coming from carbonyl and another is coming from the enolate, to make it a tight, rigid 6-membered chair-like transition state. Now, if we write the Z enolate and the that carbonyl compound with a bigger group in the pseudo-equatorial orientation, then it is very clear that when the Z enolate undergo the reaction with the C double bond O, in that case we will be getting the syn product. By adjusting the picture, it is easy to identify the way I have written here the favorable transition state. Methyl is above the plane of the Z enolate, so methyl will be up means a beta orientation. Now coming to the carbonyl side ki aryl group is on the plane and the hydrogen is below the plane, so definitely the OH will come the above the plane, because the main carbon chain we are writing on plane in a zigzag way. So the OH will be above the plane and the next carbon ki methyl also will be above the plane, which is very clear by investigating the favorable transition state. So hence from the Z enolate we will be getting the syn as a major product. Now let us proceed to little deep of this discussion. As in the previous few minutes back I have told that this type of diastereoselectivity comes on the way when the prochiral enolate undergoes the reaction with the prochiral carbonyl. Means here both the components are prochiral. That enolate has the enantiotopic phases and the carbonyl also has the enantiotopic phases. Now the descriptors for the enantiotopic phases are the psi phase and the re phase. Means that sp2 hybridized carbon has the three groups. These three groups, if we put the priority 1, 2, 3, if 1, 2, 3 are in the clockwise manner, then that phase is called as the re phase. If it is in the anti-clockwise manner, 1, 2, 3, if they are arranged in the anti-clockwise, then that phase is called as the psi phase. So the carbonyl group compound will be having the two phases, re phase and the psi phase. Equally, the enolate also will be having the two phases, re phase and the psi phase. So if we combine these, there will be four options will come: re, psi, re-psi and the psi-re. So out of these four combinations, two combinations lead to the syn product and the two combinations lead to the anti-product, as simple as this. So now we are going to solve that thing, means when the Z enolate is giving the syn as a major product and E enolate gives the anti as a major product, in terms of re phase and the psi phase of the prochiral carbonyl and the prochiral enolate, which phase is interacting with whom, so that we are getting the syn product and from the Z enolate, and E product, E enolate gives rise to the anti product. So the way we have written our aldehyde, that aldehyde ki top phase is the psi phase and definitely the bottom phase will be the re phase. So it has the enantiotopic phases, as already I have told you. Priority wise, oxygen is the first priority, aryl is the second priority and hydrogen is the third priority. The way we have written, that is 1 to 2 to 3, means oxygen to aryl to hydrogen, it is in the anti-clockwise. So the top phase is the psi phase and therefore the bottom phase, which we cannot see, that will be definitely the re phase. They will be arranged in a clockwise manner. Now coming to the Z enolate, the methyl bearing center, which is involved in this aldol condensation by forming the carbon-carbon bond. So that side only we will be doing. So the priority is double bond is the first priority, methyl is second priority and the hydrogen is the third priority. So therefore it is in the anti-clockwise. So top phase is the here also the psi phase and the bottom phase is the re phase. Now the top phase of the Z enolate is undergoing the reaction. So the psi phase, the Z enolate has the psi phase. The way we have written here is the psi phase is the top phase. Now when it is attacking the carbonyl, then OH is coming in the top. So therefore definitely the Z enolate is attacking at the back side of the carbonyl. So back side of the aldehyde is the re phase. So the psi recombination means the psi phase of the enolate interacts with the re phase of the carbonyl to give rise to the syn product. So now in case of the syn product which we are getting from the Z enolate, so this is actually we are getting by the re-psi combination of the two components, means the re phase of the Z enolate preferably interacts with the psi phase of the aldehyde, or the psi phase of Z enolate interacts preferably with the re phase of the aldehyde, gives rise to the syn product as a major product through favored 6-membered chair-like transition state where we do not have any unfavorable interactions. Now when the Z enolate and the aldehyde, if they combine with the same type of phases, means the recombination and the psi combination will give rise to the anti-product, which is the minor in this case, and this proceeds through the unfavorable transition state, means which has the higher transition state energy because of the unfavorable 1,3 pseudo 1,3 syn diaxial interaction between the aryl group of the carbonyl component and the alkyl group at the O minus bearing center of the Z enolate, so which will lead to the anti-product, and as because this is passing through the unfavorable interaction, so this anti-product will be the minor product. Now when we consider the reaction of the E enolate in place of the Z enolate, that completely reversing happens, means in this case when the re phase of the E enolate interacts with the re phase of the carbonyl, otherwise the psi phase of enolate undergoes the reaction with the psi phase of the carbonyl. In that case, this reaction proceeds through the favorable transition state, will give rise to the anti-product as a major, and the reverse combination means the re-psi approach leads to the syn product, which is the minor product because of the unfavorable 1,3 pseudo diaxial interaction between the aromatic ring of the carbonyl and the alkyl group at the O minus bearing carbon of the E enolate. And finally, we can summarize for the anti-product through E enolate in an exactly similar way what we have done for the Z enolate, that here in this case the similar combinations means recombination, otherwise the psi interaction between E enolate and the aldehyde will give rise to the anti-product as a major product, and the opposite combinations means the re-psi combination gives rise to the syn product as a minor through the unfavorable transition state having higher transition state energy because of unfavorable 1,3 pseudo diaxial interaction. Thank you.